So what I'm trying to cover next is a particular library, okay, and the name of the library is called as the numerical Python. Okay, have you heard of what is called as a numerical Python? Right, so we are starting with a particular library, right? So libraries are written in such a way that, right, they have the collections of all the functions, all the functionalities that are required for a particular type of application. So as the name suggests, you see here, we have what is called as a numerical Python. So the name numerical Python is going to suggest that, right, you are going to deal with the numbers, right? Whenever you are not worried about any other formats and you want to deal only with numbers, right? It is a sophisticated interface that you can use to store or to operate upon, right? What is called as the denser data types. Whenever you have a huge data set present, like matrix, right? 100 into 100 matrix, you see that it's actually a huge data, and it is all the data points are very similar in the sense they are of the same data, right? So now you can think that, okay, it's like I have a list, right, which is also going to be can be considered as a right matrix, very much similar. There is a similarity. So if you get that doubt, right, that is very much similar. NumPy arrays, we are also creating arrays here, right? The NumPy arrays. So we will never call numerical Python now onwards. We'll be simply calling that as NumPy. Okay, so NUMPY. NumPy is the short form. So NumPy, if you try to create an array, that will be very similar to the list that already we know. Okay, but there is a difference, right? What are the differences, right? We will try to explore that in this particular session that is related to the NumPy. So there are two important libraries we are going to cover, right? The out of which the first library, which is actually a very basic library, it is called as a NumPy, and the second type of, or the second library which we are going to discuss, that is also pretty much important when it comes to ML, machine learning, deep learning, etc. Right? It is called as a pandas. Okay. So anyway, we'll see that in a while. So right, in order to use it, you have to import it. Okay, it's not directly available in the sense it's not like you cannot call the functions present inside the NumPy directly. So you have to import NumPy. So it says, yes, if it will be normally there, right, in any installation. So when you import, it comes into picture. So if you don't get any error here, means, yes, you have NumPy available in the most default format. So first thing first, you need to check what version it is, right? Most of the time, you may have to use a specific version. So you need to check that whether that version is present or not. So NumPy dot double underscores version, after that again double underscore. This will show you which version you are currently using. Right now my system uses 1.23.1, right? Maybe with different versions that may be present in your system, but most of the time that doesn't matter, right? Okay, right? So how to update something, right? How to update the NumPy, etc. I have given a very detailed explanation in the notes, okay, that you are going to get after this session, right? So similarly, you can actually use even the collab for checking the same the version that is present over there. Okay, fine. Now, normally what we do every time, I cannot use NumPy dot something. So you can use a short form for that. It's called as aliasing, right? So this is one very important concept that comes whenever we use various libraries inside Python. So this is how you try to assign an alias for a particular say library. So when I say import, I just have to say import NumPy as NP. This is a standard what you call alias name that is given for NumPy. Everywhere you see the code, right? Generally, people use NumPy as NP. So that every time I use any function inside NP, I can simply say that NP dot absolute, NP dot say ALENS, NP dot add, like that I can use it. Okay, so NP. Now onwards, I don't have to tell NumPy every time. I can simply use NP. Easiest way. Okay, this is what is called as alias. Okay, so you can check that what is NP now. If you type simply NP and press enter, it says that, okay, there is a module called NumPy, and this is where it is located in my computer. Okay, so inside Anaconda, in the environment, there is an environment called GPU in my system. So inside that library, right? So various packages, NumPy, like that. So this is what, right? It says. All right, so that's how it is. And whatever we discussed yesterday's session, first half, try to recall that, something like this. NP, you type a dot after that, and then you check with a tab, right? What do you expect? Everything that is present over there, it should be visible. You can see that these are the various functions that you actually brought in just now, just to perform the numerical calculation. You see, everything is there. These were not there in any of the functionalities available in the Python by default. You see, there is, it's a sine function, right? Sorry, I'll just type it again. So you see, there is sine, cos, etc., sine, hyperbolic, tan function, right? Many things are there, right? So everything, right, that is available inside this NumPy, you got it. Okay, everything is there. So this is how you check. All right, so the same thing which we discussed yesterday is still present over here. And also you can check, right, with the question mark also. Okay, so you see that it gives a detail saying that it is a, right, it's a module. This is where it is located. And you have the basic documentation related to the NumPy is available. It comes up, right? It's like you are accessing the help. Okay, so this is what you should not forget anyway, right? How to access the help whenever I get something which I don't know. Okay, fine. I hope should be fine. Now I'll go ahead and I'll try to show you, right? Okay, let's try to have a comparison between the list and the NumPy list. Okay, so let's try to make a comparison. All right, so this is going to give you a very clear idea that why we prefer, if you are going only with the numbers, why should you prefer NumPy rather than using the list by default? Okay, so this gives you a clear-cut idea. For that, I'm trying to spend some time here, but still, right, it's worth spending that time. So let me try to create. This is a NumPy technique, right? NumPy array I'm trying to create. Okay, so that is np dot a range. Give a number 1, 2, 3, 4, 5, 6, 7, 8. Let me see. Okay, 8. Right? It's actually 10 to the power 8. All right. So this is what I try to create. Okay, it got created. I'll also create a list. Right? You see, the list is actually what we already know now. So that's what I'm trying to create. So this is list of, it's a range, right? Okay, again, I'll try to enter the same thing. So this is 1, 2, 3, 4, 5, 6, 7, 8. All right. So that also gets created. So there is no as of now, when I look from outside, there may not be any difference. Okay. So to understand what is the difference, right? Let us try to, right, do something here. Right? Let me try to, okay, there is what is called as a magic function, which is used to do particular tasks in Python. One such thing is to calculate the time. So when I execute a particular line of code, how much is the time taken by the machine to do that? We can check it. Okay, so we can check that by using its time, right? This is, if you try to write something like a percentage followed by a keyword like time it, that means it is a magic function. It's going to do some magic for you. That's all. Okay, so I have given a clear details and what are the various magic functions available, etc., in the yesterday's notes. Okay, so when you refer that, you understand. That's not a very important concept. That's why we never discussed when we went through the coding part. Okay, all right. So this is a magic function. I'm trying to compare the list and the NumPy array. So I just have to demonstrate something to you, right? So that's why I'm doing this. So I try to calculate the time, right, for in range 10. All right, I'll try to do my array 2 is equal to my array into 2. Whatever is there in my array, right? You see that there is a range, right? Starting from 0 to 9999, 7 nines, 99999. That's actually this range, right? That's there in my array. Same thing is there in the list as well. Okay. But now I'm trying to perform what is called as, right? I'm trying to multiply every number by 2. But how many such operations are there? It is 10 to the power 8 operations are there. Now I'm trying to calculate how much time my computer takes. This number, whatever you get as answer now, may be different when you run on your system or when you run on a Colab. Okay, so just see this. It is taking some time. And you see, answer is not coming instantaneously, right? Okay, so you see, this is something like approximately, right? I got 479 milliseconds, right? So you understand millisecond into 10 to the power minus 3. So 471 into 10 to the power minus 3 is the time taken by my machine to do this calculation. What is the answer? Don't worry, I don't want, right? Because every number is doubled, right? My array is my array into 2, right? So many numbers, 10 to the 8 numbers are multiplied by 2. To perform that, my computer took 471 milliseconds plus or minus something, right? This is when my input is a NumPy array. Okay, NumPy array. I use the NumPy for that. Now you see, I'm trying to do the same thing with the common list, right? The general list which we were discussing so far, right? That also we have already created. In that, I'm trying to, right, perform the same operation. So again, I'll try to calculate the time for that. So percentage time it. Once again, I'll use a for in range and my list 2 is equal to, I'll try to apply the list comprehension itself, right? I'm trying to apply the map function. So that is x should be square, x is equal to x into 2, right? For x in my list. Every x in my list perform x squared. X into 2, 2x. Okay, so let's run that. Okay, let's wait for the answer. You have to wait now, right? Answer will not come quickly, right? That's the major difference. If you use a simple list for this purpose, you may have to wait for a longer time. You see, still I don't have answer. Now it's already 3, 4, 5, 6, 7 seconds or more than that, 8 seconds or something. Okay, so, right, it takes time. So major difference is that, right, lists, right, are capable of handling not only numbers. If you remember yesterday's concepts, or if you open up the yesterday's class notes, you can understand that in a list, we actually have provided inputs of lists as integer type, floating type, characters. Also, we have passed what you call as the strings, we pass the tuples, etc. Right? Inside a list, one element can be another list, right? Nested list, etc. Nested tuples can be present inside a list, right? So because of that, you see, right, that list is going to be it's a data type which can handle anything in that. But, right, when I create a NumPy array, it can handle only the numbers. Numerical values can only be stored over there. Because of that, right, the data type, whenever I say that, right, these are my data, right, I have to create a range of numbers, right? So machine understand that, sorry, machine understands that everything is of the same type, right? So when everything is of same type, reading, writing, operating, etc., becomes very easy. So that is why it was faster. Now you see, when we created a list, right? List is expected to handle each and every type of data. So the data, each location gets a different size of memory than the NumPy array. So because of that, reading, writing, etc. will take more time. You just compare here. See, this is 12.1 seconds. This was just 4 seconds, half, right? Maybe this is something like half a second. This is like 12 times, 12 seconds. So 24 times more, right? Compared to the previous tools, right? So that is the reason, right? Why there was a requirement of developing a new tool when to handle only numerical data, right? Otherwise, you see, if I use a list for my 1000 into 1000 table, right? How much time it will take, right? Again, not just reading or writing is only option. You may have to square everything, then you have to cut something, then you have to cut the rows, do something with that, etc. Many things are supposed to be done, right? Before we go to the machine learning part, right? So we have to do what is called as a data pre-process, right? That would have taken a lot of time if you don't have something like this. So I hope the requirement is very clear. Why you went for the NumPy when you already have a list? Definite question that might come somewhere, right? When you maybe you attend an interview, or maybe right when you try to defend your right internship thesis or something. Definitely a question might come, right? So then you should be in a position to answer that. Okay, so this is very important. That's why I try to discuss this. Okay, so we'll start the concept now with creation of a array. All right, so let me say the first thing is, let's say that we have a list with us. Okay, so my list is equal to list of range, say up to 10. Okay, so now I know that this is a normal list. Okay, so my list, you see it is a list, right? But how do I convert this list into the NumPy array? Very simple. Okay, so you have to use what is called as NP, because NP is a must, because I'm using this from the function which I'm going to use now is inside the NumPy. So NumPy is assigned with a what you call as alias name, that is NP. Okay, so NP dot array, right, and pass on this, right? So something like okay, you don't have to pass anything because its name is available, right? So my list. Okay, so that's my list. Now you see the difference. I'll try to assign something to this. Okay, maybe this is my array is equal to like this. I'll call this. Now I'll type my array. So that is this. Now look at the type. Type of. See, now you see this is completely different. We are seeing this for the first time. It says it is a NumPy n-dimensional array, right? Actually, everything NumPy uses only one type of data, right? That is an n-dimensional array. Everything is assumed to be n dimensions, right? N can be 1 here. Right now it is n is equal to 1. The same data type can hold multi-dimensions like two dimensions like a matrix, or like 3 dimensions, 4 dimensions, and so on, right? You can increase the dimensions as and when required. We are coming to that at a later stage. Okay, so this data type is what is common in, right, the NumPy. Okay, now we see the difference. As I already mentioned, NumPy stores everything in the same data format, right? So that should be justified by this. Now I'll try to enter something here. So np dot, this is array, right? I'll try to enter a list here. That is 1, 2, 3.5. You see, I'm entering a float in the middle. Okay, 4 and 8.09, etc. You see, right? It actually creates an array, but you observe something. This is 1 point something, indicating that when I entered, this is a integer. Okay, this is an integer. But you see here, this is a float because there is a 1 point something, right? So that means that the NumPy array stores everything in the most common format, right? Common format in the sense int can be converted into float, but if you convert float into int, you lose the data. So it automatically converts everything into float. So 1 point something, 2.0, 3.5, 4.0, 08.09. That's what is happening here. It is showing only dot here, indicating that it's getting converted into the NumPy. You see here, the previous case, everything, right, you had is integer. So there is no dot after that. So 0 point is not there. It's a 0. 1 point is not there because it is an integer. So that's the difference. Okay. Now let us try to create, maybe I'll try to show you how do you create a multi-dimensional case as well. Okay, all right. So this is the easiest way to do that. This is one of the way to do that. Okay, np dot. Okay, I'm creating a array, np array, right? So I just have to tell, right, what I'm supposed to create, right? So this is I'll just tell what is the range I want. Okay, so I'm saying that range some I, comma, I plus 6. Whatever I is there, I plus 6 is this, right? You have to add 6 to that and increment that starting from I, it's a range, right? If I write range 1 to 4, it is right 1, 2, 3. That's what is creating. Now, starting from I till I plus 6 is what I'm saying, but increment that by 2. So that's why this is 2 here. Okay. So this is what is my range for I in 1, 3, 5, 7. Let's see. It's creating an array. So I is in 1, when I is equal to 1, see it is creating I plus next number, and that is I plus 2, then I plus 2 plus 2, I plus 4. But when I write I plus next 6, right, it is outside, sorry, this second. Okay, so you can see that what happened now is I'm creating a range I to I plus 6 with the 2 increments starting from I is equal to 1. Then the next number is I equal to 3. So 3, 5, 7 will be created for that. Then when I go to 5, this is 5, 7, 9. So just understand what this range is doing. This becomes easy for you. This is one way, right? But there are many other ways of doing that. One of the ways is that I can create an n-dimensional array and I can put all values are 0. This is the most widely used one. So I'm trying to give an example. Okay, so this is np dot zeros. Okay, I want 100 such values, right? So you see 100 zeros are created, but by default, all the elements in the NumPy array, unless you specify, it is considered as a floating type. You see, everything is a float, 0 point, 0 point, 0 point, everything is 0 point. So how do you change that? NP array, right? I'm saying, okay, NP zeros, sorry, not array, zeros. I want, say, 1000 zeros, but I don't want float there. I'll say D type. Okay, data type is equal to int, saying that everything should be integer now. Now you see, we created 1000 zeros. Okay, and all are integer. There is no dot after 0. So previous case, right? This is a default case. Everywhere, after every 0, you were seeing a dot over there, indicating that was floating. Now you see this is not float, this is int. Okay, then another widely used function is creating ones. I can create any size data. Every entry should be 1 for us. Okay, so that is np dot ones. Right, I'll just have to specify how many rows, how many columns. That's also possible. So I'll just say that 4 rows, 6 columns. Okay. Again, if you don't specify, right, it will be, let's check what happens. It's a float. Okay. When you don't say, it is always float. There's no meaning in saying that d type equal to float. Okay. So because float is the one which always comes. But if you want integer, you have to specify. After that, write a comma, right, over here. Write a comma and say, okay, I'll write a different one so that when you read this, it should be clear for you. Okay, so this comma d type equal to int. Now you see all ones are created with that particular size. Okay, so now obvious question comes into your mind that how do I create a particular n dimensional array with all values are same? I want to specify. I don't want 0. I don't want 1. Okay, I want some other number. Okay, so how do I do that? That's also possible. That is also very useful. Okay, so for that reason, I'm trying to write something here. Okay, so that is np dot, the function is full. np dot full. Specify your size. That size, whatever you require. Okay, 6 rows, 3 columns. All right, and just to specify the number that you want to put over there, say 5 values, 3.1416. See, we created 6 rows, 3 columns. That's a matrix, and every number, every value present over there is what you specify. This is also pretty important. Creating all zeros, creating all ones, and creating with a specific number, right? That I want to be present as a particular entry. Every entry in my n-dimensional array is what we require. Okay. Then the next important aspect is to create a series of numbers. Like we use the range, right? Range of 10 means what it created? It created 0 to 9. In the same way, can you create that over here, right? Yes, one thing you already know that I can deal with the range, but that is associated with the list. If you simply say create that range, list of something, it creates a list. I know that probably I have issues with the list now. So far it was very fine, but when NumPy came into picture, right, we all have issues with the list. No, we don't want to use list because we know the reason. So what do you do? What is the option that we have so that we can create a range here, right? So it is possible, right? Very simple. np dot, now it is not range, it is a range. Okay, np dot a range. Then you have to tell where you want to start, okay, where you want to stop, and what is how you want to increment. Say 18, right? I want to increase by 18, 18, 18, 18, right? Every time. So you see, you created, it looks like a list for you, but don't worry, it is not a list, okay? They don't have any other representation. It's an array. They put an array over there. Outside that, they write array to specify that it is not a list, it is an array, okay? Is it fine? Right. So there is another thing that normally we need to do, right? I have a range, right? Range in the sense, say 0 to 10. I want to create I want to cut this range into equal number of pieces. I can specify the number of pieces, right? I want to cut 0 to 10 as 5 equal pieces. What do? You know how do you cut that? Okay, so this is what we are trying to do. Okay, so that is np dot lins lean space, yeah, linspace. So you just have to tell from where you want to start, 0. Where you want to end, say 10. I want to cut this into 5 equal pieces. Right? So this is what we do normally, right? We know how to get that. But when this number becomes something like a real numbers, this thing becomes very difficult. For example, right? I'll try to do this. So 0 to 10 cut into 5 pieces means you know what to do. So this spacing is, and we can understand. 0 to 2.5 is 1 piece. 2.5 to 5 second piece. 5 to 7.5 third. Then this is equal to 4. So when I write 5, so 5 numbers will be generated indicating that there are 4 pieces. Okay, so that's what is the meaning, right? 0 to 2.5. In the sense, cut this into 5 numbers. 5 numbers equally spaced is what I asked. Okay, so same thing I'm trying to do now, but you see, right? This is the usefulness of this particular command, right? So np dot, it's a namespace, right? I want to start from 2.5, 2.2, let's say. I want to go with the 132.9. See, this can be anything, right? And I want to have, say 27 pages. I don't know how to do this manually, right? Even if you ask me this question, I don't know how to do that. But you see, it creates answer in no time. 2.2, next number is 2.7.22, next is 12.25. Every gap is equal, right? So you try to create 27 numbers between 2.2 and 132.9, which are equally spaced, right? That is the usefulness of this particular command. Very useful, all right? Very widely used, so I'm stressing that. Please remember this particular function. Okay, then what if I want to generate random numbers, right? Randomly, any number is fine for me, but I want to generate it random. So for that, this is the function np dot random dot random. Okay, yeah, np random dot random. You just have to tell what is the size that you want to create. Okay, so I'll just say that I want 4, 4, right? So random numbers between 0 and 1 are created. Is it okay? Then if you want to follow a particular distribution, for example, if you remember in probability, we have discussed about various distributions, correct? So you want to follow a specific distribution means, right? You are going to use the one which I'm going to write now. So that will be np dot random dot, you will specify normal. Normal is a distribution, okay? np dot normal, right? You are going to specify what is the mean value, because it's a probability. Probability distributions are always going to have a particular mean and a particular standard deviation. For example, mean is equal to 3 and the standard deviation is, let me say, 2. Okay, and I have to say how many numbers I want. I want, say, 6, 6, right? I want to generate 6 into 6, 6 rows, 6 columns with a particular distribution, and each number, right, should have a mean of equal to 3 and standard deviation equal to 2. So this is how it looks like. Okay, all the numbers that are generated here, right, is going to have mean equal to 3, standard deviation equal to 2, and 6 cross 6, that is 36 numbers are being generated. Okay, so now obvious question is that what if I don't want real numbers like this? I want integers, right? Can you do that? Yes, that is also possible. np dot random dot randint. Go to this. Again, it's a very much similar. I want to start with 0, and the highest number I want to look, I want to see in my in whatever array it generates is 9, means you enter its next number. So 10. Okay, 1 to 10 is what I want to create. Specify a size, that is 3, 5, 3 rows, 5 columns. So you see, minimum number is 1 that I can see in this because I specified 1 here. So this is the minimum number that you want to see. This is the maximum number, one more than the maximum number. So 10 is entered means 9 is visible. You can see the highest number that is present on there. And the size is 3 cross 5. And what you have is all are integers because I specified random integers. Okay, very important. Only important topics I'm covering in the session. The material which you get will have an elaborated discussion of each and every aspect of this. Okay, so kindly go through that in detail when you have time. But you have to remember what we are discussing here because that is absolutely necessary. So one more concept is that you may have to create identity matrices, right? So how to create that? Pretty easy. np.eye, right? And in the bracket, you specify the size. 4 means it is a 4 cross 4. 6 means 6 cross 6. 100 means 100 cross 100. Identity matrix will be created. Okay, so a straightforward way of doing that. Okay, so any doubt you have, please let me know if you have any doubt. All right, so that's good, right? I hope you are coping up well, right? You are doing the homework, you are trying to read the materials given. I hope that, right? So with that, right now, let's take a tea break, quick tea break for 15 minutes. Let's join back at 4:15. Okay, come back at 4:15. We'll continue. Please take a break. We'll continue the NumPy. So far, we were discussing about the creation of various types of arrays using NumPy. Okay, so to continue with that, now we'll discuss how to find out the various attributes related to the array which we have created. Okay, so first let's try to create some of the simple arrays, right? Let me try to show you. This is a recall session. Try to recall how do we create the one-dimensional array. Okay, so let me try to write something like np dot random dot rand int. I'll specify, say, 100 comma size equal to 15, right? So a array is created whose size is, in the sense, whose dimension is one-dimensional array. Number 100 says that highest number should be 100. Within 100, you can generate any random integers over there. 15 is the size. Okay, if you count how many entries are there, that is equal to 15. Right. So this is how you create one-dimensional array. All right. Let me go to the two-dimensional case. Right. So that is np dot random dot rand int. Right. I'll specify, say, 1000. I want to create anything within 1000. Size equal to, now you see the size has to be a m cross n value, right? So I'll just write 5 comma 6. Let's see, 5 rows, 6 columns, and the highest number is 999. Every number is less than 1000 is used over there. Okay, to create this. Very similarly, let's go for a three-dimensional case. np dot random dot rand int. Okay, I'll specify a number, say 10, size equal to, I'll enter 3 values here. Okay, so that is 2 comma 3 comma 4. Okay, just visualize what is happening. Right, so the first 2 says 2 copies. 3 means 3 rows, 4 means 4 columns. 3 cross 4 is the matrix size. 2 such matrices I'm creating. So that first matrix here, second matrix is behind that. So whenever I say such thing, right, it is actually a third dimension is added. So, right, so you can make a difference here. I'll try to put this into one of the say array name, right? Say my array is equal to, I'll try to put this over there. Okay, I'll just copy this and paste. Okay, so my array is that three-dimensional array. Now, if an array is given to you, how do you identify the various details of that array? Like we call it as attributes. Okay, so the first attribute that you can identify is my array dot ndin, saying that n dimensions. So see, it says this particular array which you have entered has 3 dimensions. So how to find out? Nd. All right. So the next attribute is called as a shape. Okay. So that is n, or not n, but my array dot shape. So shape is the keyword used to identify size of each of the dimension. So you see 2 comma 3 comma 4. There are 2 copies. Each copy has 3 rows and 4 columns. So that's how you try to decode this. All right. So that's the second attribute which you can identify. Then we have the total number of elements in that, right, in this array. So how much it is? 3 into 4, 12 into 2, 24. I want to get an answer 24 from that. So you can identify, you can find out that by using this. This is my array dot size, right? So 24, yes, there are 24 elements in this. Okay, so then what is the data type? That also we can identify. All right, so to visualize that, I'm going to use my array dot dtyp. Very useful. Okay, it is integer 32-bit representation has been used, right? Depends from system to system. Normally int 32 is the common one for integers. Okay, then I want to check what is the size of each of the item, right? So I have 24 elements. Each item takes some space in the memory, right? So I want to check that. So obviously this is 32 bits. So in bytes, I'm going to get the answer. So 32 bits means how many bytes? Anybody? Can you answer? Put your answer in the chat. So I know that it is 32 bits, right? So 32 bits means how many bytes? Because my answer is going to come in bytes now. So I want to verify that the answer coming here is true or not. Correct? So tell me the answer. 32 bits, how many bytes? Okay. My array dot item, that is what is called as item size. Yes. Okay. We have few answers with us. Let's just verify. Yes. Many of you are answering. Okay, so most of the answers say 4. Let's verify. Okay, so I'm getting answer in bytes. So it says 4, right? So each number that are stored there takes, right, 4 bytes. All right. Then what is the total bytes then? Can anybody answer? If each of them takes 4 bytes, what is the size of this particular array? There are 24 elements in this particular array. So what's the answer? What's the total size of this array? Can anybody answer? My array dot, yeah. So once you have answer, right, I'll try to write the code here. Okay. So there are 24 elements, each element taking 4 bytes. In bytes, you can give me the answer. Okay. All right, so we have answers coming right now. So let's check them. Okay, the command you use is n bytes. Yes, yes, absolutely perfect. 96 is the answer. Okay, so when a unknown n-dimensional array is given to you, how to identify the details of that, right? So now you know the different, right, keywords you are supposed to use after the name of that variable, right? Dot, check that. If you want to check a shape, dot shape. Total elements, size. Okay, the number of dimensions, ndim. The data type is this. Each size of each element, item size. Total size, n bytes. All right. Okay, so now I think we have a, okay, let me bring this here. So let me copy this itself so that I want to create an array. I don't want to go with a 3-dimensional array. So my array is equal to this one. So I know that my array contains 15 different elements. Now, how do I access the various elements of that array? It's the same way how you used to index the lists. All right, so let's check that. My array of, there are 15 elements, so 10 should work. Okay, so you can see the 10th number is 69. Right? So like that, you can check that, right? Also, you know that there is a negative indexing possible, right? So I also will make you to remember this. My array, the last element can be directly accessed with the -1. So let me print and show you that so that you can remember. Okay, so the last number is 81. By using a index value -1, indexing, if you use an index as -1, you can always go to the last column, right? In general, so this is 81. Right. Then you want to access different number, you can definitely use it. Okay. Fine. Then let me try to access a multi-dimensional array. So I already have a multi-dimensional array with me. So two-dimensional array, I'll try to go with. Okay, this is the one. Okay, so let me try to write that. So my array is equal to, I'll put this so that a two-dimensional array gets created. Right? It's a 2D, right? It's a matrix. Now, how do you access various elements? So how do you access the first element? First element can be accessed my array, right? Use a square bracket, 0, comma, 0, indicating that 0th row, 0th column. That is the first element, 471. Okay, like that, I can definitely use it. Even the negative indexing is possible here. Refer the notes that you are going to get today to get more details about this indexing part. Now, actually, right, you can modify the values as well. It is right, something like it is a mutable case, right? So I can try to do this. My array of 0, comma 0. I'm trying to change my first number. Okay, I'll try to make this equal to 100. You see, right? Try to print the my array now. You will see that the first element, which was 471 previously, now it is updated to 100. Right? So that you can even make the modifications. Okay, modification is possible. Right? Remember one thing, right? That now this particular my array is made whenever it is created, it is supposed to hold only the integer values. Okay, so that is the important thing, because the NumPy is its advantage is that it is made to hold a single data type throughout. Whatever you use, it's the same thing. It will automatically makes sure that everything will be in the same type. We already have seen by using one integer, few floats, etc. Later on, everything was converted into float. Now I'm trying to show you something related to that. What happens if you assign a float value now? Because I know that any of the value I can change. If I assign a float value to this, will all of them will change to float, or something else is going to happen? Let's check that. Okay, so my array of 0, comma 0, the first number, I'm going to assign a value equal to 3.1416. Okay, assignment happens, there is no issue, no error. No error is thrown saying that no, you cannot assign. But something should have happened, right? Let's check that. You can see the 3.14 is actually converted into int. Only the 3 has been assigned over there, because all the 24 now, how many numbers? Sorry, I forgot. 30 numbers, I guess, 5 into 6. Every other number is actually int. That means only for one number, converting everything into float is not right, suggested, because the whole array, n-dimensional array, was declared to hold only the integer. So whatever you assign will be converted into integer, and you will be right having that. Okay, so that's the important thing which you need to remember. Whenever you assign, you should be careful, right? Fine. Let's go for the next concept, that is slicing. I have the arrays created, how to create various types of arrays, like 1 dimension, 2 dimension, 3 dimension, how to assign common numbers throughout, how to assign ones, how to assign all zeros, how to assign random numbers, how to create the numbers, the random numbers following certain distribution, and how to put random integers over there, everything we check. This is what is mostly needed. Okay, so for our ultimate goal, right? So I have covered that in pretty much detail now. So the next thing is, I have an array, I want to cut a piece of that, I want to slice it out. So the next concept that we are going to look now is called as the slicing. Okay, it's called as array slicing. So let's look at the slicing option. So let me create a my array that is equal to np.a a range. I'll say that 10. Oh. So look at my array. This array 0 to 9. Okay, 10 numbers are created over there. So now I will try to slice it. I want to read the first 5 numbers, right? What you used to do in the list, same thing you are going to apply here. Okay, so that is my array of, yeah, sorry, it's not this thing, it's a square brace. So everything till 5. Okay, first 5 numbers. Then I want to read from 4th to 7th. In other words, 4, 5, 6, if you want to read, you can write something like this. My array, starting from 4, you want to read till 6, but you have to write 7. Okay, so 4th to 7. Okay, I want to read every number in the array, but at a count of 2, right? So my array, everything at a count of 2. So see, first number, then leave the next number after that. So 2, then 3 is not there, 4, like that. Okay, so you can do this, right? I can also do, I can specify from a particular point you start and keep going ahead. That's my array. I want to start from the index 3, okay, and increment the 4, right? So only 3 and 7. Start from 3rd, 3, okay. Then 4, 5, 6, 7. So next number will be 7. Then 7 afterwards you calculate 8, 9 dash dash. So it's not there. So only 2 numbers have been printed out. Okay. Also you can even okay. One very important thing, very advantageous thing is that how to reverse an array. It's very easy now. You don't have to write a big program. I'll show you. Right. My array of everything with -1. In the sense, there is no increment, there is decrement. In the sense, I will start from, right? I have to start from the last and I keep coming down. So this is what is going to happen now. See, it starts from 9. 9, 8, 7, 6. So, right? So array was there. It's an n-dimensional array. You are writing it from the last, right? So reversing is very easy now, right? Nobody can ask you a program to write a program to reverse something because it's just one line. Okay, I hope this is clear, right? Let me know if you have any other doubt on this, right? Let me just see, or I will go with another example. So I will go with the 2-dimensional case. How to slice the 2-dimensional arrays is my next concept. Okay, I created a 2-dimensional array in NumPy. So this is what is the array. This is how it looks like. Right. So now I want to, right, perform the slicing of a 2-dimensional array. So I want to see, I want to read all the rows, every other column, right? All the rows I want to read, but column wise, I'll pick first one, then second one is not there, then third one, then fourth is not there, and so on. If at all I want to do that, this is my command. Okay. My array of, you want to read all the rows. So first position is row. If you write a single column and you write a comma, it says that everything in the sense row position, I'm saying all. But when you go to the column, I want to read every other column. So I have to provide an increment of how much? 2. So that is, so first if you write something like 1, 2, right, 3, right? Oh, sorry, 1, say 6, 2, right? It means starting from 1, go till 5, right? With the increment of 2. But I don't want to do that. I want to start from, I want to consider every columns, but with the increment of 2. So for that reason, you can simply write no starting point, no ending point, but increment it with 2. You see here. So the first column is selected, second column is not selected, third column is there. 853, 167, 160 is there. Then next column is not there, this is there. Next column is not there. Right? So this is how you do that. So this is actually slicing. You can see I'm picking something from the original array. Right? So just see what it is going to do now. My array of 2, 3. Right? So this is from my array. I'll show the result so that you can analyze. Right? So this is row position says until 2. Right? Until 2 in the sense 0 and 1. So 0th row and the first row are considered. So out of these two, that is what is corresponding to, right? Starting from 0 till 2, 2 exclusive. So 0 and 1. Then the column position says 0 to 3. In the sense 0, 1, 2. So there should be 3 columns. you see here, column number 0 corresponds to 950, column number 1 is for 2, column number this is for. So I have 3 columns and 2 rows, right? Should be these two, right? So you can see that, that's how you slice it. Okay, so what if I want to read the second column, right? So how do I read only the second column from this? Can anybody suggest? My array of something I should write there. Can anybody suggest what is the command? Please type the command in the chat box. We'll verify. Okay. I want to read the second column of line number 89. That is this. That is my array. I want to read the second column. Second column. That is corresponding to this 2, 684, 941, 580 and 93. I just want that to be printed over here when I run the command. So what I'm supposed to write. Yeah, so the question is, I want to read, I want to slice this, right? Particular given array. The given array is this my array, right? I need to write a command here, right? In this command, I want to write something so that the result is only this, right? The second column which you see on your screen, that is 2, 684, 941, 580, and 93. Sorry, and 93. Okay, this is what I want to be displayed. Only those numbers I want to display. You can write it row wise, column wise, doesn't matter for me, right? I want only them to be coming as an answer. So what I'm supposed to write here is my question. Okay, so that's the question. Please try to give an answer. I want to read all the rows of a specific column. All the rows means what? How do you write? Look at the previous example. See, I wrote all the rows and specific column here, right? So something like that. So here I'm writing 0th and first row, right? 0, 1 and second column, right? So this is column number 0, column number 1, column number 2, right? And row wise, this is the row number 0, this is row number 1, right? Something similar to this, right? Something similar to this, I have to write something over here. Okay, so okay, let's try to write. We have one answer. I'll just try that. So answer says like this. It is an error. Okay, because I'm not saying specifically read all rows. Okay, so if you want to read all rows, all is represented by what? All is represented by a column. Single column says read all the rows. If I tell write, see, when I write A comma B, A corresponds to the row position, B corresponds to the column position. Okay, so you see here, this means all the rows, but I don't want all the columns. I want only one column. That column's position according to, right? My question is this, that is 2, 684, 941, 580, and 93. That means it is corresponding to the first column. First column is number 0. So this is the second column with the number 1. So I have to write here, that is equal to 1. All the rows of first column. See, 2, 684, 941, 580, 93. So just I need to understand where I should put what. Okay, I'll change the question. I'll give some time for you to get adjusted to this. Okay, it takes some time. Absolutely fine. Make mistakes and learn. All right, so that's my point. So my question is that how do I read the third row? What is my third row? 777, 941. This is the one which I want to print now. Okay, right? Build a logic and tell me what you are trying to write here. Okay, so that is my array of something. What I'm going to write inside this braces, I want you to tell, right? Corresponding to the third row. Okay, right? So let's see here. Row number 3, first position has to be specified. That is corresponding to which row you want to read. So 0, 1, 2. So third row means it is 2. Okay. And I want to read all the columns of third row. So all means it has to be this. Right? Perfect. That's right, Sanath. Right? Right. Now you see, right? I want to read, say, let me form another question for you, right? I want to slice the fourth and the fifth column. Okay, column number 4 and 5 corresponding to 803, 929. Okay, so that's my question. My next question is, I want to read the two columns under 803 and 929. Below that, whatever is there, I want to print that. Okay, so that's my question, right? So please try to answer that. So again, I'm supposed to write something like this. My array, this. Whatever I have to write inside this bracket, you can tell. All right. Yes. So meanwhile, there is a 0 is an answer. Okay. Okay. Any doubt, Gauri? Do you have any doubt with our discussion? Because I see a different answer on the screen. Please let me know.
Sir, it was by mistake.
Ah, okay, okay.
Sorry, sir.
Absolutely fine. No, no issue, no issue.
Yes.
Please go to the next question. Okay, so okay, we have an answer coming here. So that says my array of all the rows. That is correct because I want to read every row of particular columns. You see the columns I want to print is 803 and 929. Below that, whatever you have to write. Okay, so the answer says 2:5. Let's check. So when you say 2:5, it actually taking 2, 3, 4, 3 columns. I don't want 3, I want only 2. So yes, 3:5, will it work? Let's check. Yes, perfect. That's right. So now you see you are getting adjusted to this, right? So use this logic. Remember what you are trying to do here, right? So that you can build, you can use this whenever required. We have to slice, right? Whatever comes as a big data set, we don't want. We want a piece of it, right? How to access that? This is the logic. Okay. So try to work more on this, right? Go through the notes that you're going to receive today, right? Go through that in detail. There is a lot that we have a lot of examples, right? Given for a two-dimensional array, multi-dimensional array. Also, we have given some of the examples. Okay. Fine. Now, let's go further. The next concept that I want to discuss now is called as a reshape, right? I have a given what you call n-dimensional array, which I might already have created. So now what I want to do is I want to reshape it. I want to convert that into a different shape, right? So let's look at that example. Okay. So my array is equal to, let me say, I try to write it as a nth dot arrange 10, and I'll you see that it is one-dimensional array. Okay, now I want to reshape it. So how do you reshape? Right? It is maybe I'll call it as my array 2 is equal to, I have to tell which is the array that I want to reshape. Okay, that is my array dot use a function called reshape. Okay, reshape and tell the size that you want to convert this. So there are 10 elements, right? 10 elements in the sense you can have so many number of rows into columns so that the product of number of rows into columns remains equal to 10. So I can convert this into one option is 5 rows, 2 columns. Okay. My array 2, let's visualize. You see, it got converted into that. All right. So a reshape is the one which converts, right, your which changes the shape of the array, right? So fundamentally, you try to understand that. Okay. Now, let me say I have, right, a what you call as okay. Let me show you before going further. Let me show you another option, right? If you try to use the reshaping option, right, you can convert, right? You can convert a array into something like I can try to convert that into a two-dimensional what you call row or column matrix. I can actually convert into that. So I'll just try to show you that now. Okay, so my array 3 is equal to np dot array of, right? Let me try to enter the values here. So 1 1 comma 2 2 comma 3 3 comma 4 4 comma 5 5. Let me say, okay, my array 3 is what I want to print. You see, it's actually a normal array. Okay. I can actually convert, I can do a reshape now. Okay, so the reshape in the sense my array 3, I'm saying that dot reshape this into, right? I'm saying that 1 row 5 columns, right? Now you see this is a 2-dimensional piece. Okay, so previous one was simply 1 dimension. Now this is a 2-dimensional piece. Now you see, I try to perform what is called as, I'm trying to add a new column to that. I can try to do that. Okay, let me try to do that. Say my array 3 my array 3, right? This is the original one. I can use a reshape. My array 3 dot reshape, and I'll specify 5 comma 1. Okay. See, it was a row, it gets converted into a column, right? So one of the way to perform the transpose is this. Okay, there is another option here, right? That is actually called adding a new axis to that. So if you look at the my array 3 now, it's still the same thing, because the previous case was I just converted that into this and printed over there. Now my array 3, right? I'm trying to perform what is called as, right, all the rows wherever you want to add an axis, because it was a row matrix, correct? I want to convert this into column means, right? It is like this. I want to convert like this, right? In the sense you are adding a column to that. You are actually converting this into a column, means column wise you need to add an axis to that. So now you see all the rows. You understand what is this? My array 3, right? Inside the square braces, I'm writing column, right? Means all the rows, comma. Column wise, I'm trying to do what is called as np dot new axis, saying that make a new axis in the column. Just see now what happens, right? So, right, you are free to do this. If you don't know the size, simply use this, because normally we will be using this itself, okay? Because I don't know what is the size of my data, right? It may be 1000 into 10,000. It may be 10,000 into 20,000. I don't know what's the size, right? So whenever I want to convert something row wise into the column wise, I just use this. Okay, so this is very important, right? That's why, right, I'm doing this. Right. Okay, so this part is what we are going to call as the reshape part. Okay, reshape part is also very important. So that's why we have dealt with that, right? Next is a joining and splitting of the arrays, right? How can you join? How can you concatenate? And how can you perform the what is called as a split, right? So we'll see that now, right? So let's try to create maybe one or two arrays for us now. So the first one, I think my array uh, is equal to np dot array of enter. This is the first one, and my array 2 is equal to np dot array of, I'll enter say 222, 444, 777. All right, so this is the next one. Now, right, I can actually perform the easiest way to joining by using what is called as a concatenation. So np dot concatenate, simply write, use a square braces, because we are always, it's actually a matrix, so we have to put a square brackets, right? Just mention the name, my array, comma, my array, oh sorry, my array 2. So see the result, it's a concatenation. All right, fine. Then let me try to create another array now so that I can show you the vertical concatenation. So far it was like first array here, followed by that I attached to that with another array, right? So now I want to do vertically, right? So this is how we can try to do that. Okay, so I'll try to create my array say 3 is equal to np dot, I create one, any method you know so far you can do that. Okay, np dot random dot, I'm creating integers, right, up to 1000, and I want a size equal to, my array has size column 4, so 2 comma 4, size equal to, let me try to write this, 2 comma 4. Okay, so it creates a my array 3. Okay, it is created. So now what my next thing? I have to attach this, I have to concatenate this below the my array, right, which is already present. So I'll just type this, my array. See this, right? So how can I do that? I can do that pretty much in a very easy fashion, right? So vertical concatenation is possible, right, using this technique, right? I'll just show you that. np dot okay, that is np dot concatenate, right? I'll specify what all the various things are that I want to do. I want to concatenate, right? I want to concatenate, say, my first one, that is right, my array. So that I want to concatenate my array 3. Okay, so let's see what happens. It's an error, right? Because one of them has only one row, other has 2 rows. I cannot concatenate horizontally. That's why this is an error. Okay, I just have to specify, right, by saying axis equal to, so, oh, sorry, axis 0 is again, right, row wise, my mistake. Let's make it 1. Oh, that's also an error. Let me just check. Axis 1 is out of bounds for this. Let me quickly check what I made as a mistake. My array, let me check. Where is my array? Oh, sorry, that is slicing. Okay, that is not a two-dimensional case, I guess. Where is my array? Okay, this is my array. We shape 1, 5. Okay, so I have to do that. So my array is equal to my array dot reshape 1, 4. Okay, so now this converts. I'll check. It should be, yeah. So you see that it gets converted. 0 means I'm attaching below that. So row wise attachment happens. So column wise, you want to attach something like one after the other, means it axis equal to 1. So remember, axis indicates 0 means one below the other. So row wise, you discuss something, means in a column, if you are looking something, when I say I'm looking at a column, I'm actually looking at rows. Okay, row wise, you want to do something, you put axis equal to 0. Right. At the same time, if you want to attach something, right, column wise, I have something here. To that, I have to add a few more columns here, right? Means I have to mention axis equal to 1. So that is another method, right? Now you know how to attach row wise and column wise. Okay, right? So that's one thing we have done so far. Now there is another method to do this, right? So let me type them once again. Let me just show them. Okay, what is my array? Let me visualize that. Let me also visualize my array tree. Okay, so this is these are the two arrays. Now I can use a built-in function to do the attachment, right? So that is called as VStack. VStack for vertically stacking, right? So that is np dot VStack. Vertically stack. What you want to stack, you just have to specify. That is my array, comma, my array. Oh, sorry, my array third one. Right? So you get the same answer. You don't have to do all this, right? Simply you can use VStack is a function. Okay, inbuilt function you can use, you can, right, get that. Similarly, there is another function called HStack. Horizontally, you can stack one after the other. Okay, so that is, that's what you can even do that, right? So if required, please do that. Right, so details of the H stack and the example is also I have given in the notes, okay, which you are going to get today. So please go through that and work it out, right? Write the code. I always suggest write the code, okay? So you may see that, okay, you may see something in the notes and you may understand, right? So that is not enough, right? So you have to write, then you have to type the same codes. It may be the same code, or you may try to implement the same thing with your own logic. Absolutely fine, but do that, you practice, right? Write the code, absolutely necessary, so that, right, we will be able to write a larger code when we go to the actual concept of machine learning, deep learning, data science, and many more things. Okay, so that's why it is absolutely necessary. So far, we were discussing about the I think concatenating, right? Various types of concatenation, right? Now we'll go for a split option, right? So let me try to create a new array, right? Let's try to create that. Okay, so maybe I'll try to write my array. Okay, only 4 numbers we have. I'll try to create this again. Okay, so that is my array is equal to np dot 50. It creates an array, right? You can even check that. My array. Okay, so it prints out like this. Now, right, I'll try to split this, right? I can use a function called np.split. All right, so np.split will split the array in the required format. Okay, so let me try to show you that, right? Let me try to call it as say A1, array 1, array 2, okay, array 3. I want to split this into 3 arrays. All right, so I have to pass a list of indices where you want to get the split, right? Index value where you want to have a split. Okay, so this is what I want to do, right? So let me pass something like this. So this is np dot split, right? Simply pass, tell which array you want to split. That is my array. Come on, I have to pass a list, right? That's like this. I want 3 pieces. So definitely the first piece will start from the index 0. So 0 you don't have to specify. So I want 3 pieces. So I need 2 more indices. Something like, you see, I want to cut this from 5 and I want to cut this from 10. Okay, so 5 means what is the index value? So maybe this is 6 and this is 11, I guess. So let's try that. So 6, 11. Okay, so we'll see what is A1 now. This is the array 1. Oh, okay, 5 is not included there. So if I want to include the 5 in the second one, then you need to write this also as 5, right? Okay, let me make that change, or you understand how it's happening here. Okay, so let's say I want to write A2. This is A2, 6 till 10, because 11 actually falls in the next. Okay, so A3. Okay, so that's how you can split. You can use the split function to split a given n-dimensional array into any number of parts that you want. All right, so very similar to this, we can actually use the concept of splitting. The same function will be used, that is a split, right? You can use the same thing to split the what you call as the 2-dimensional matrices, 3-dimensional matrices, and so on. Okay, so again, many examples we have, right? So you can refer to the material that we are passing on and understand that. Okay, so that is also important, but right now we are not having much time to discuss each and every aspect as of now. Okay, so we'll move ahead. The next concept is transposing or swapping the axis, right? So this is what we are trying to do now. So the first one I want to write is, say, my array is equal to np dot, it's a range of, let me write 15 values, and I'll try to convert that into, right? I can do the reshape here itself. Okay, this is supported in Python. So 3, 5. Just see what is my array. Right, as suggested, it creates 15 numbers. It's a range, then reshapes that into 3, 5, 3 rows, 5 columns. Now, the simplest way to take a transpose is my array dot capital T. See, converts rows into columns, columns into rows. So we are going to see this in future, right? Normally, whenever we are dealing with the matrix related calculation computations, always we will observe that there is a X followed by X transpose, right? So that will be very common, right? So just you just have to get adjusted to that. How to take a transpose dot T. All right, then we have what is called as the swap axis. All right, so I have another method to discuss. So I'm going to do that now. So my array, right? I'll try to create this now. np dot range. I'll try to create, say, 36 elements, and reshape. I'll create a 3-dimensional case. So 2 copies of 2, 9, 2 into 9, 18 into 2, so 36. Okay, so this is now my array. Okay, so this is how I create my array. Now, my next option is that I will show you how to use a function called swap access. Okay, so my array, you have to apply SWAP. There is swap access. Just tell which access you want to swap. Like if I write 1, 2, the first dimension and second x and y axis will be swapped, right? So you see, this is what is happening. So you see, it was horizontal, it became vertical. So 0, 1, 2, 3, 4, 5. So whatever was a row became a column now. Here you can see that it is a column. And the previous columns became a row for both of them. In both the cases, this itself is what you can observe. So this is called as swapping the axis. You may not use in a very wide scenario. Everywhere you may not see usage of this, but yes, this is also important. All right. Then, okay, let's move ahead. Let's move the various operations, right? What are the various operations that you can do between the arrays, right? So it's very important. This is also we are going to use. So let me try to create something like, okay, let me try to do something. This is np dot arrange. I'll say 1, 6. Okay, you know that this is what it generates. I'll also create np dot arrange 2, 7, so that the number of entries become same. So 1 to 5, totally 5 elements. 2 to 7, 1 to 6, that means 5 elements. 2 to 7, that's also 5 elements. Now, just look at this. This is what I'm trying to do. This, I try to divide by the second. Okay, you see element by element, it gets divided. 1 by 2, 2 by 3, 3 by 4, 4 by 5, and 5 by 6. Right? So this is called as U functions. It's a unary functions, right? I can directly perform this. It's also called as a a simple method which you can apply. It's called as a vectorized operation as well, right? So element by element, you are doing something, right? Now, right? Let me try to create another one so that I can show you the how this unary functions. It's also called as U functions because I'm using only one this thing, right? Operations, but actually I'm doing so many operations, right? 1 divided by 2, 2 by 3, right? I'm doing 5 different divisions altogether. This is valid, right? This is pretty much valid in Python, right? So there is another way you can apply a function to the whole matrix. It can be any dimension, right? Let me show you that. So let me create my array is equal to np dot arrange. I'll create up to 8. Then I'll do the dot reshape. Okay, I'll reshape it to 4, total 8 elements, right? So 4, 2, right? So this is my matrix, my array. Okay, I understand. Now you see, I'm trying to get this 3 raised to the power that my array. So every number is raised to the by 3 to the power. So firstly 3 to the power 0, that is 1. Next 3 to the power 1, that is equal to 3. Then next is 3 to the power 2, that is 9. Next is 3 to the 3, that is equal to 27, and so on. You see, right? I have raised 3 to the power that matrix. Okay, so this is right. It's actually called as a vector operation, right? Actually, this is actually even called as a unary functions. Okay, ufunc is the short form. Okay, now let's try to do something here. I'll try to show you another this thing. So for that, I will need to create my array again. I'll try to form a 1-dimensional array. This is np dot a range, say 8. Right? The first unary function that I want to show you here is, okay, let me print it out. So my array, I just want to see, right? This, okay, this is fine for me. Now I'll write my array plus 50. Every number gets added 50, right? It's again unary function. I'm applying unary operator plus to, right? Add a number, specific number to every, right? So this is also valid. My array minus a specific number. So every element will be subtracted by that. Okay, you can even do the multiplication, division, and the whole number, right? So that's a integer division. I'll show you that. My array divided by. Let me try to write 2 now. See, first 2 numbers, reminder, not reminder. So quotient is 0. So 0, 0. Then 2 and 3, it is 1. 4 and 5, you can divide twice. 6 and 7, you divide 3 times, twice. So that's what is the answer. Okay. So like that, we can apply, right? The unary functions, right? Unary functions can be negation. Unary functions can be power, right? Like I already have shown here, right? This is actually the exponentiation, the power, raising it to a power, and even the modulus can be applied. Okay, so division is I have shown here. So my array, right? Simply call percentage or whatever number you want. So that is also possible. Reminders, you can show. Okay, so those are what we are going to consider as the U-funcs or unary functions. Right? Again, we have some of the built-in functions available to do this. So you don't have to do a plus always. Something like np.add. It's an inbuilt function. You just have to tell what is my array, what is the number that I want to add. Like my array, say that to my array, I want to add 3 to that. So see the result, every number in my array, you are adding 3, right? So there is an inbuilt function. So similar to this, I have given a complete list of inbuilt functions that are available, which you can use as arithmetic operators, right? So add, subtract, negative, multiply, divide, floor divide, and you have power and mod. So these are the 8 different operators. So simply replace this add by the ones which I just mentioned, like subtract, negative, multiply, right, floor divide, etc. Many things you can apply. As and when you apply that, that particular operation will be performed. Okay, so very important, right? So please go through them in detail when you get the material today. Okay, then let me show you the absolute value. Absolute value is pretty much necessary because whenever we calculate something called as error in the various machine learning related concepts, right? You have to take an absolute value. So how to take an absolute value? I'll show you. So my array is equal to, I'll try to create a np.ara. This is a range starting from -5 to +5. Okay, so I'll show you what it is. Already you know that this is a range starting from -5 till +5. +5 is not included, so this. So what I can do, if you want to take an absolute value, you want to convert the negative numbers into positive number. So simply use ABS. Oh, sorry. You use ABS of my array. Okay, you can see that. This is how you get that. Okay, so np dot, this is ABS, right? If you want to do the same thing under the NumPy, I'm supposed to do np dot absolute, right? ABS is under the Python, right? Central Python, but you can use the np dot absolute of my array. Will do the same. Okay, you are free to choose, right? Whatever you want. Okay, all right. Then let me quickly go through what do you call as right, the Okay, the sine and cosine function, in general, the sinusoids, right? Whatever trigonometric functions we have, that is also equally important, right? So let's go to that. So let me create the list of angles now. So angles equal to NP dot LINST, you know the lean space, right? I'll say that start from 0, go till 2, 2 times pi. There is a pi value, you can enter 3.1416. Otherwise, you can specify, the NumPy knows this, NP dot pi, right? Convert this between 0 to 2 pi, get me 5 points. Okay, so I'll show you that what is NP dot pi, because you may have a doubt. So NP dot pi is 3.14159. Right, so it actually knows now. So there is a list created, angles, right? It's an array, right? Starting from 0 to 2 pi, totally 5 points you get, right? Now, right, NP dot, simply write sine of the angles. So you see, sine 0 is 0, sine of 1.57 is 1, right? Sine of 3.14 is, it's close to 0, because 3.14159 is actually pi. So pi means sine pi is 0. So look at the power. Power is 10 to the power minus 16, very small number. That's why that is close to 0. Then 4.71 is 270 degrees, that's plus minus 1. And the 6.2831 is actually close to 2 pi. 2 pi means it is 0. So sine 0 is close to 0 now. You see that it is power minus 16. Again, a small number. That's how it is. Right? Similarly, NP dot. Okay, I wanted to go for a cos, right? Cos of angles. Right? Everything is converted into the same fashion. So sine 0 is 1. Sorry, cos 0 is 1. Cos, right? 90 degree, close to 0. This is minus 1, cos 180. And this is the, right, 270, close to 0. Cos of 360, which is 1. Okay. Similarly, you can put a tan over there, TAN, to calculate that. Okay. So now I'll show you how to go for the inverse, right? Because inverse is also equally important. So I'll just create another one that is called as value. Okay. So value is equal to NP dot array, right? Let me create 1, 0. Sorry, I need to put a comma between 1, comma 0, comma minus 1. This is a value. Now I will write NP dot, this is sine inverse is arc, ARC, arc sine of the value. Right? Answer comes in radians. So 1.57 radians. Okay. Right? Then 0. Sine inverse of 1 is, right, 1.57. Sine inverse of 0 is 0. Sine inverse of minus 1 is minus 1.57. Okay. So 1.57 is, in a sense, plus 1.57 says plus 90 degrees. This is minus 90 degrees. Okay. Similarly, you can go for NP dot ARCCOS, arc cos of, right? You just write the value. Okay, so the values are, if you have a series of values with you, you can take the inverse as well. Similarly, you can go for inverse tan, right? Inverse tangent, etc. You can definitely use. Okay, so I can also write, I can try to write NP dot EXP. So this is e to the power. Okay, NP dot EXP of val. Right? So it is e to the power every number. What is a val? You can see here. This is a array. So e to the power 1 is 2 point something. E to the power 0 is 1. E to the power minus 1 is 0.3678 and so on. Like that. Okay. So then if you want to raise something 2 to the power, right? 2 to the power something means, how do you do that? It's again a NP dot EXP2. right? exp2 means it is 2 to the power. Simply, if you write e, it is a normal exponent. Okay, so 2 to the power, if you want to do 2 like this. Okay, let me move further. How can you take the log, right? Because we are dealing with the numerical Python, right? So it is absolutely necessary that we have to deal with the various, various functions, okay, associated with that. So I'll create a my array now. So np dot log. When I write log, it is a natural log. It's not base 10, okay? Log of, right? Let me write my array, right? It is base e, okay? Something natural log we call, right? So this is what is natural log. But if you want to go to the base 2, base 10, etc., right? I have to specify. That is np dot. I want to go to the log 2, let's say. So this is log 2 of my array. So it is log to the base 2. Similarly, log 10 is the log to the base 10 of this. Okay, like this you can calculate that. All right, so that's very important. All right, in addition to this, let's go to, right, some of the what you call as there are some of the important functions that you can use, right? Something like a beta function, gamma functions. I think you have studied that in maths, right? At least higher engineering maths, somewhere you might have studied. So let's quickly look at that. Okay, that's the last part which we are discussing, right? I need to import something from. Anyway, we are not going to discuss in detail about this particular tool, right? That's called as a SciPy. SciPy is a specialized what you call as a library which consists of scientific calculations in Python. So for example, if you want to take say fast Fourier transform, that is a scientific calculation. So that is present inside SciPy. Okay, so numerical Python helps in most of the numerical calculations. SciPy helps with the scientific calculation, right? So anyway, we are not going to touch that for the timing. But if you want to use something like beta functions, gamma functions, or right error functions, you might have come across the error functions, etc. Right? So if you want to use them, you have to go to this particular module called as SciPy. Inside the SciPy, there is a special, right? Because right now what we are discussing is a special function. Okay, so let me quickly show that. So from SciPy, you import special. Okay, so anyway, it's actually giving you some warning, right? This version of SciPy. Okay, let's see. It's saying that I have a different version than what is expected, right? Maybe because usually I keep on updating my my Python version. So maybe when I updated for the in a recent past, it got updated to some other version. Okay, let's see. Let's see whether this works or not. Okay, so first let me try to create a list. Okay, that's this. Now it's a special because it is present inside the special dot gamma function, right? I want to use special dot gamma of the values. Okay, I think values is what I have used. Okay, so let me make this is value so that this also can remain values. Okay, so this is the gamma value of those values. Like gamma of 0.11 is 8.61. Gamma of 2 is equal to 1. Gamma of 5 is equal to 24, and so on. Okay, so like that you can calculate gamma. Very similarly, right? Let's try to write a beta function. Okay, so that is special. Special dot beta. Okay, so remember beta gamma functions from maths, right? So beta value of, right? I have to go with all the values. Okay, it's a value See, beta has to be specified, beta of m comma n, right? I have to write a n value here. Some randomly I will show you. So beta of value comma 3, if you want to calculate, this is how you calculate. So the 3 makes no sense here. I'm just writing here because beta is always calculated with the 2 values, beta of m comma n. Go back to maths if you want to recall this. All right. Then one more thing I want to show you, that is the error function. Okay, so for showing the error function, let me create another list here. Okay, so right, there are various error functions that are supported here. So special dot, one error function is ERF. Okay, maybe these error functions are, you might have studied error functions when you discuss about the probability of error of receiving something in a digital communication, right? So that may be just, I'm trying to give an example where you might have studied this. Okay, error functions are very common in communication, right? So when I send one from a transmitter and you receive a 0 on the other side, what is the chance of error, right? So that's what we are trying to calculate, right? Whenever you want to do something like that, we have to use the error function for a representation purpose. Okay, so special dot ERF. Let me write this as value. Okay, so this is value. All right, so this is the first type of error function. There is another error function, ERFC. Okay, it's a complement. That's also you can take the values, right? And the last error function that it supports is inverse. Okay, so that is special dot ERF ERF inverse of the value. Okay, so right, these are the various error functions. So error functions may not come very occasionally, but before that, whatever we have discussed here, right, they are absolutely necessary.